let's talk about the second main topic in calculus, which is trying to determine the area underneath a given curve. So even though that may be an interesting problem by itself to study, what I'd like to do next is just to talk about some kind of motivation for why we might care about that kind of problem in an applied setting. That is, first of all, consider a cost function that is not constant throughout its whole domain. So in many cases, the cost of producing X items decreases with the more items that you actually produce. So in that sense, we can sort of define a cost function, as I've done here, whereby if you produce X items between 0 and 10 items, it's going to cost $100 per item. The cost of producing 10 items to 20 items, the next 10 items, is dropped by half. Okay, so if you are more than 10 items, and if you produce between 20 and 50 items, it's going to cost $20 per item. So the more items you produce, the cheaper it is. Okay, this is just a cooked up example, but it's certainly an idea that does have some truth to it. Now I've gone and plotted this particular cost function, which is certainly not constant on its domain. It's just a step function, which we're used to already. That is, the function has constant values on certain portions of the domain. That is, if you're producing between 0 and 10 items, the cost is $100 per item. If it's between 10 and 20, it's $50 per item. And if it's between 20 and 50, it's $20 per item. So let's compute, in particular, the total cost. So what if I'm looking for the total cost of producing 50 items? Okay? And you'll see that it's actually a very simple idea, but can be extended, and it's related to this notion of finding the area underneath a given curve. But let's go ahead and compute this. So to compute the total cost of producing 50 items, certainly it's going to cost, for 10 items, it's going to cost $100 per item for all items, all number of items produced between 0 and 10. It's going to cost $50 per item between 10 and 20, and $20 per item between 20 and 50. Okay? So all I've got to do is just add up the total number of items that I'm producing, right? In fact, if I produce 5 items, that for each item I have to spend $100 if I sort of take this value up. It's $100, okay? So the total cost of producing 50 items, well, I'll just write total cost as TC, and let's say TC of 50, is going to be, well, it's the cost of producing, let's say it's $100, or we can already see here, it's $100 to produce the first 10 items. So it's $100 times 10, because it's 10 items for $100 a piece, right? So $100 times 10, that's the total cost of producing the first 10 items. I've got to add that to $50 per item multiplied by the next 10, okay? But there's 10 items here, right? So for the next 10 items, it's going to cost $50 per item. Therefore, I'm taking $50 and multiplying it by 10. And I finally add that to, it's $20 per item times the next 30 items, right? Okay? For these next 30 items, it's only going to cost $20 per item. So again, it's $20 times 30. And when I add them up, I can see that what you're going to get is 10 times 100. You're going to get 1,000 plus 500 plus $60. And in the end, you're going to get $1,560. So that's the total cost of producing 50 items. And all I did was just add a bunch of stuff up. I'm just adding, right? That is, if it's $100 per item for the first 10, I just take those 10 items and multiply it by 100. If it's $50 for the next 10, I just take those next 10 items and multiply it by 50, because it's $50 per of those next 10 items. And for the next 30 items, it's going to be $20 per item. Add all of that up, that's the total cost. Okay? But take a look a little closer. Actually, this can be thought of in terms of a geometric problem. Think about it. For this first piece, $100 times 10, what is that? That's really, if you think about it, that's going to be 10, here's 10, right? That's the width of this little box here, this little rectangle, times 100, which is the height of this rectangle, right? So here's 100 is right here. So in fact, this little quantity that I have in red is really the area of this first little rectangle that I've drawn, okay? But it's the rectangle underneath the curve here between 0 and 10. So I'm going to draw in this, or fill in this box. Okay, so that's the area of this little piece that I've drawn in red. Similarly, if I look at the second piece that I've added, this second piece is just going to be $50, which is going to be the height of this second box. Here's $50. Okay, that's the height, right? The height on the Y. Times 10, which is the width of this box, right? Here's your 10. So the area of this little box is just going to be this little second square here. It's 50 times 10, right? It's height, which is 50, times length, which is 10. Okay? So height times width, that's the area. And similarly, geometrically, we can think of the area of this little box here as $20, which is a height. It has a height of 20, a height of 20 in the Y, and a length of 30, right? 10, 20, 30, a length of 30, that's the area of this little box. So in fact, this is again the area of that box. So geometrically, we can see that the total cost of 50 items is going to be the area of box 1, I'll just call it A1, here's A1, plus the area of box 2, here's A2, that's the area of box 2, plus the area of box 3, A3. So in fact, the total cost of producing 50 items for this particular function is just going to be the area of this box, plus the area of that box, plus the area of the third box. Okay? And just seeing that shows you that in fact there's a connection between total cost, which is an actual value that has an applied meaning to it, and the area underneath this particular curve. Okay? This curve happens to be a step function. It's just in little chunks here, but it's still a curve. And we can still find the area underneath that curve. That's going to give me the total cost. So that's one application of this notion of finding the area underneath a given curve. Okay? And notice how I'm below the curve C, but above the x-axis. Okay? And I'm just looking for the total area.